a little bit, and we're also going to look at how to use Desmos for this word problem. So it says we want to use a continuously compounded formula. So we have, that is the amount we have equals the principal times e raised to the RT, where a is how much money we start with, p is the, a is how much money we have, right, after we continuously compound it. P is how much we started with, R is the annual interest rate, and T is the amount of time in years. So we have Mr. Burst, he currently has $250,000 in his retirement account, and it earns 8.5%. Look and see whether that's possible today, because you'll never get that kind of interest. How long will it take him to earn at least $1 million? All right, so when we have to not use an equal sign here, right? We're working on inequalities because it says at least $1 million. So we want this side, how much he's earning, is bigger than $1 million, right? Because we want him to have at least $1 million. And we probably could include an equal sign there either way. But okay, so when I start to solve this, this step is kind of skipped, but they're dividing both sides by 250,000. So 1 million divided by 250,000 is 4, right? That is less than e raised to the 0.085t. And we want to solve for t. So we've been practicing. When we want to solve for t, we need to take the logarithm of both sides. And because this is base e, we're using the natural logarithm. That's why it's ln. So we have the ln of both sides. This comes out in front. And then the ln of e is just 1, so that's why it's not written anymore. So we just have 0.85t, and we divide both sides by 0.85. And when we simplify that, we get about 16.3 years. And let's just look and see. You should be able to solve this algebraically, but if you wanted to solve it using Desmos, I just want you to see how you have to really think about your scale. So we're looking for when y is at 1 million, and you can't use commas in Desmos. They don't like it, which makes it a little bit hard. That's 100,000, that's 1 million. And then the rest of our equation was 250,000 times e raised to the 0.85, and we use x instead of t because Desmos likes x and y. And we see nothing. Right? And you could just start zooming in or out, but I want you to see that you can think about this. We already saw the answer was 16.3 or less than 16.3. So let's leave -10 so we see it, and maybe we go up to, I don't know, 30, and we can make a step by 1 or 5. That just changes it, makes it look kind of nice. Now, for here, we're going to go pretty far down. Let's go down 100,000. We know we need to get up over 1 million, so let's go like 1,000,002. And yay, and it automatically was doing nice steps for us, so we don't have to. And we can find the value here. And if we wanted to make this an inequality, we could just say, and you can even see we can make this if we say, you can see the intersection here if we're looking at two graphs, and we want it to be more than, right? So it needs to be this side of the graph. Right, and if you wanted to see this as all together, we would have 1 million is less than, can this let me copy paste so I can make it, oops, copy, paste, right? It's going to show us we're looking at this side over here. And if we don't want to see these two, oops, we do want to see that one. And this lets us see that we're on this side of the graph, right? We're up here, where it's greater than. All right, so either way, we can get this. We can get it algebraically, right, as shown, or we can use Desmos to solve.